and welcome back to another Unity 5 tutorial. In the last session we've set up our UMA so we can display expressions and use the expression player, and we've got everything ready to write our lip sync script. So at the end of last session I was talking about this audio file that I've downloaded.
The birch canoe slid on the smooth planks.
Beautiful.
Glue the sheet to the dark blue background.
Exactly. And this file, I'll put the link once more in the description. We're just gonna rename it to test audio, since this is the reference. Oh no, excuse me. UMA test audio, which is the reference we've used in our script. And in order to keep things clean, we're gonna open up this new folder called audio and move our audio file into this folder. So actually those scripts, I don't know, it's gotten a bit messy here, so excuse me. Hey, I'm just gonna move all the scripts in this folder. Yeah, this script we didn't write that together, I think. That was for testing the areas, so it should actually be in here. Anyways, I'll just leave it all here now. Sorry. The important script for now is the NPC simple lip sync script. So now we just need to delete our test UMA once more and create a new one, because last time we still did not have the test audio file. And if you now look at your audio source after creating a new test UMA, you can see that our audio is set. So this is important for us. Now we move to our simple lip sync script. So the basis, or kind of the entire script, what we're gonna use is based on a Stack Overflow post by, let me have a look, Aldo Naletto. I don't know how to say that name, but he's posted a few answers on the same topic, similar scripts about how to get a certain range of frequencies, how to sample that and get or actually just many posts on how to analyze audio in general, but that is one I found and what we're gonna use. So I've modified it or simplified it a little bit, but yeah, let's see how we do that. So first we need to set up a few variables, so just bear with me. We will look into what they all mean and how we use them later. So we need a float, an array of floats called f data, frequency data, and we need a maximum frequency, and we set this one right away from audio settings dot output sample rate divided by 2. So the output sample rate of Unity, I think, is usually 48,000 hertz or 48 kilohertz, and we need half of that value, whatever it is. If it's 4041, then we still need half of that. So this is why we set it up like so. And then we want to set up 3 range values. So let's see. The first range will go from 46 to 8192, and this will be a public int and samples. Then we have a range from 200 to, let's say, f max. We are not allowed to say that. How do we do that? Actually, we don't even need that much. So let's say just 20,000 should be fine. We'll talk about that in a second. This is called, it's another int called flow. And now you can actually just copy and paste the entire section and call this f_high. So low we set on, let's say 300, and high we set on, let's say 800. And the samples we set it on 256. Okay. Now in our start function, the first thing we want to do is set our f data array. It's a new float array with n samples. So whatever amount we have here will be the amount of values in our float array. Let me think, do we need anything else? Well, of course we need our expressions. It's a get component, UMA expressions. So remember at, actually does that work? Oh, I should. We've set up the expressions in another script, so they are added to our test UMA, and here we just get a reference. Then, oh yeah, now in an initialize script, here we first add the expressions, and then afterwards we add our NPC simple lip sync script, so it is safe to just call get component on UMA expressions because that component has been already added. Then we need a reference to our NPC audio. Get component audio source. And in order for something to happen, we just gonna play this audio source right away. So this is not an wasted line of code. We just uncheck that here. The reason is we don't want our UMA usually to talk right away, so we just uncheck it now. Actually, let's do that here to be safe. Audio source play on awake is false. By default it's set on true. We don't want that. We want to be able to tell our UMA when he talks and when not. So now this is the basic setup for what we need. And now we need a function returning a float. And just going by the Stack Overflow example, we call it bandVol. So, and now we start working with everything we've set up so far, and I'm just gonna explain as we go instead of trying to explain something you cannot see yet. So we have our NPC audio, and an audio source has got a function called getSpectrumData. And what that does is it provides a block of the currently playing audio source spectrum data. So we actually will get for all the frequencies that matter to us, we will get information on how loud this frequency is played, or how much this frequency is apparent, is in our audio sample, what we are looking at. And So we need to fill in the components. First it takes a float array of samples. Well, we do have a float array of samples, so we use this f data, but it's important to note that the length needs to be a power of 2. So this is why there are those weird values in here. In the Unity docs it actually says that the minimum is 64, the maximum is 8192. That's why I chose those values. Now, right now this is just a slider that just can take any value. We need to fix that later on. For now we just know that it needs to be a power of 2, and we will only use values with a power of 2. So f data is our first. The channel, we just take the channel 0. So you have in a stereo audio file you have a left and a right channel. Since we're talking about speech audio is usually mono. So we can use channel 0, but you just need to check this. If you work with stereo files, then you might revisit that. So, and this one is a Fourier transform, don't even know how to say that in English, function. It basically will do all the math work for us. It will take the audio signal and work with it so we can get some data out of it, to put it really, really simple. So, and here we take FFT window dot Blackman Harris. So there are different algorithms how you can actually get values here. So of course we could play around with them. In the example I found, this one was used. Same in the Unity docs, so I'm just gonna stick to it. So, and now it's important to note what will happen. This is the algorithm we use. This is the channel we take the data from, and this is where we will store the results. So we've set our array to have such a length of right now 256 values, and we will do that in just a bit. We're looking at values between the frequencies of 300 Hertz and 800 Hertz. So we're gonna take 256 samples in this range and just look. Actually, no, that's not true. We're gonna take our, let's just write that here. This one would be 24,000 Hertz. And we're gonna sample that. We're gonna chop it up in 256 pieces. So good to have a calculator in hand sometimes. So we can calculate every 93.75 Hertz we will have one sample. I hope that makes sense. So we chop up this value in 256 pieces, and later we want to check what of those values are between 300 and 800, and those are the relevant values for us. Let's put it in code. So we need to use a floor to int because we have an int value to work with. Now we have our lower end. We multiply it by the amount of the samples divided by the maximum. So this is this helps us now to find the sample that has the first value in our range. So this will be N1. This is the index of the value, the first value in our range. And the last will be N2, the last index. So we use, I can just copy and paste everything. And here we use F high, like so. now we need, we want to count up the volume. So we set sum to 0.0. And now we just iterate through all the values that are of interest for us. So, sorry, int I equals n1, I less than n2, and I double plus. And all we do in here is add the values. So we have our f data, that is the result array from our getSpectrum function. And now this is all the relevant indices between 300 and 800 Hertz. So we can just put in I in here. And we will add this, we will add these values all onto the sum. And at the end, we will actually return the sum, but we'll still, yeah, we want to get an average on it. So right now we've just added it all together. So in order to get the average, we're just gonna use linear average. So here we just calculate the amount of values we are working with. So, and that's it. That still is missing. Now this little function will give us some values, and we're just going to have a look at it, what kind of values we get. So let's take a float, since our function returns a float, call it float value equals bandwall. And then we do a debug.log value. So if you're developing something like that, the debug log is your friend, because you can just always put out some values in order to see what is actually happening right now in my program. So, and now let's see, the lip sync script is in here, values are set, we're just gonna use the default values, and we hit play. Oh no, we got division by 0. How could that happen? Division by 0, that would mean f max is 0. Oh, that means I cannot just set it like so. I think. Let's try that here. Sorry, I didn't try that one before. I just thought, oh, that doesn't give me an error. It should work. So it might also be that just this value, the output sample rate, is not set for whatever reason. Let's try that again.
The birch canoe slid on the smooth planks.
Okay. Now we don't get an error anymore, but we also don't get any results, which is not so nice. Let's just see. Sorry, I'm just gonna do some debugging here. Let's just see if our function is being called, our update function. So it is called, and we've got a value. Okay, so let's say, oh, I see already, sorry, my bad. I'm gonna save it, and now I've had set this one wrong.
On the smooth planks.
That's sometimes the simple
Glue
things.
the sheet to the dog.
So I'm gonna start it again, and then
the
we will go with our
slid
values.
on the smooth planks. Glue the sheet to the dark blue background. It's easy to tell the depth of a well. These days, a chicken leg is a rare dish. Rice is often served in round bowls.
Okay, so what we note is we get values out. They don't tell us much. If we would follow along, we would see that as our speaker is speaking, the values are a bit higher. And as it's silent, then it's a bit lower. And as we have some noises that shouldn't be in, we get some really high values like, oh no, those are really low. Oh yeah, never mind. So no really high values. That helps us only. So, but yeah, we're here in a range that is way below 0. So we need to look back to, let's look back to our character.
The birch canoe slid on the smooth planks.
So
Glue the sheet to the
now
dark
we
blue
see,
background.
I'm just gonna turn
It's
him down a
easy
little
to
bit.
tell the depth of a
So
well.
now we can see we got values
These days,
here
a chicken leg
that
is
are
a
between
reddish.
0.00
Rice is often served
and
in round bowls.
something like that.
The
So
juice of
we,
lemons makes fine punch.
if we
The
now,
box was thrown beside
where
the
is it?
pop
Jar
trunk.
open and close, put in
The hogs were fed
0.0001.
chopped corn and garbage. 4 hours of steady work.
Like that is
faced
not
us.
gonna do anything.
A large size.
So
in
we're
stock.
just gonna basically arbitrarily, like there's no real system behind it now, we just need to find a way to get our values in a range between -1 and 1, because this is the range. Oh, sorry, I only see it as I'm in play mode. Whoa, that is sad. Yeah, I need to check that later. And there's the bell. Never mind. And there we are again. It's half a day later, and I just figured there won't be any more quiet minutes, so I just gonna finish that quickly. As you can see, I've changed a bit here, and this is basically the part that I've added in the meantime. So we get the value from a function, use a multiplier to get it in the range between 0 and 1, clamp it between 0 and 1 just in order to make sure we don't have any wrong values here. And here I get the value in the range between -1 and 1, multiplying by 2 minus 1. That's all there is. And I'm using a damper variable. I declared up here. This one basically says we're now not going from -1 to 1 because the mouth super closed and super wide open is not what we need for talking. So I've decided to use 0.7. You can try different values here. And this gives us, the variable names are not that great right now, but anyways, so I've called it norm value and log this value, and then I just pass it on to a function, just checking here if our UMA expressions are ready. That's what we set here. And now this function will move later on into the UMA expressions script, but for now it's here, that's okay. Let's have a look. Oh, I'm not even sure if that needs to move. Anyways, so we keep it here. This is a function taking our float value, and I just take this value and apply it to the jar open and close. And then I just apply for the tongue up and down a random range variable between -0.8 and 0.8. So all this is not really great yet. I'm gonna clean it up next time, I promise. It still will not be great after that, but it will look a bit better. Anyways, let's just have a look at the results.
Glue the sheet to the dark blue background. It's easy to tell the depth of a well. These days, a chicken leg is a rare dish. Rice is often served in round bowls.
Great. So you can see it's far from perfect, but the mouth is moving, and the mouth is only moving once we hear something. And it's also moving accordingly to the dynamics of the speaker, which is still improvable. But yeah, we're gonna fix that up next time a bit more. I think one thing that's obvious is that the movements are going from, the mouse is going from open to close way too often, way too fast. So we will just have to think of a way to smooth that out a bit. And then, yeah, as I said, it still is far from perfect, but it's something you can work with for now until you find something better. So I hope that helps. Thank you for watching and following along, and see you next time.